Hello guys, let us start our review with the problems from chapter 4, graphs. We have the function y equals 4 cosine 3 secant x. Let us find period and amplitude of the function. With the amplitude is simple. It is just this coefficient that is multiplied by cosine or sine function. So the amplitude is 4. Period can be found by the formula 2 pi divided by b. b is the coefficient inside the cosine, so b is 3 over 2. We must divide by this fraction. So 2 pi we divide by 3 over 2. And when we divide by the fraction, we multiply by the reciprocal, so we can write 2 pi multiplied by 2/3. So in the numerator, we multiply 2 pi by 2, so the 4 pi. In denominator, we have 3. So the period is 4 pi over 3. The amplitude is 4. You will have several very short questions like what is the period, what is the amplitude, what is the equation of the graph for this graph. So let's look at this graph. So first we must decide whether it is sine or cosine. Yes. So let us look at these two graphs. So you see that the graph on the right, it starts from the middle value, so in the middle. So both sine and cosine functions are limited also, but sine wave starts in the middle and cosine wave starts either from the minimum or from the maximum point. So for example, we can, if you continue it like this, you know that both cosine and sine can be continued infinitely without any limit on the left and to the left and to the right. So this is also the cosine wave, but this is from this maximum to that maximum, but this time it is shifted. So if you want to give the equation without shift, horizontal shift, then we will better consider this wave represented on the picture. And when it starts from the minimum, it means that it is negative cosine. Yes, this cosine is multiplied by a negative number. That's why it starts from a minimum point. Also, we can find the amplitude. So the difference between the minimum and maximum value divided by 2. We have 5 in the upper half, 5 in the lower half. So the half of this total distance is 5, so the amplitude is 5. So we multiply by 5. We have the coefficient negative 5 in front of cosine. And the last we must find b. So what is the period of this function? One period is the interval from minimum to minimum. So on this graph it is pi over 3. So period is pi over 3. We need to find b, and just it 2 pi over p over pi over 3. So b is 2 pi divided by pi over 3 or multiplied by its reciprocal 3 over pi. In the numerator we have 2 times 3 times 5, so 5 times pi, 6, and pi in numerator and pi in denominator can be cancelled out, so this is just 6. So b is 6, and we finish writing the function equation 6x, negative 5 cosine 6x. the second graph. This time we have a sine function. And standard sines starts with increasing. So this time here we have decreasing function. It means it is also multiplied by a negative number. The amplitude, so sine is situated between -4 and 4. So the amplitude is 4, multiply by 4. Now the period. So that one complete wave is situated between 0 and 8 pi, so the period is 8 pi. So period is not from 0 to 0, but it's the interval where we have both minimum, maximum. And after one period time, the same wave will be repeated. So now we can find b. It is 2 pi divided by period. 2 pi divided by 8 pi. Pi numerator and denominator will be cancelled out, and we can divide numerator and denominator by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. b equals 1/4. So we have the function 1/4 x. -4 sine 1/4 x, or sine x over 4. Let us consider the following function. Y equals 1/4 sine 5x minus 2 pi. So the amplitude of the function is this coefficient, 1/4, so a equals 1/4. Then the period of the function can be found by the coefficient by x. So this coefficient, that's the number that's multiplied by x, is b. b is 5. So period will be 2 pi divided by b, or 2 pi divided by 5. So period 2 pi over 5. Then we do not have vertical shift, but we have horizontal shift. So, and we cannot tell directly because the shift is the number that is subtracted from x, not from 5x, but from x. It means we first have to factor out 5. 5x minus 2 pi. We must factor out 5. So 5x divided by 5 is x minus 2 pi divided by 5. 2 pi over 5. So, and this is the horizontal shift. So horizontal shift equals 2 pi over 5. So the horizontal shift is the number that is subtracted from x. So if you would have plus here, then the horizontal shift is negative. Now we have minus, so horizontal shift is positive. Let us consider the next graph. So we want to determine the equation for this graph. So you see, now this time it is shifted vertically. It means so sine or cosine function is added or subtracted some number. Let us see whether it is sine or cosine. You see, it starts on this one period interval. The function graph starts from maximum and ends at maximum. So we better take cosine function. Of course, you can describe it with a sine, but it will be not so easy since it will be a horizontal shift. So we take cosine for this. So it is shifted horizontally downward, and the horizontal shift is not the distance to the maximum, it's the distance to the middle line. and middle line is at 6. So the graph is shifted downward 6 units. So minus 6 is the horizontal shift. The cosine itself is positive since it starts from maximum. So it is not negative cosine, it's positive cosine. It must be plus here. What about the amplitude? The amplitude is the distance from the middle line to maximum or to minimum. This is the amplitude. 6 minus 4 is 2, or 2 cosine. And what about the period of the function? One complete cosine wave is 2 pi. One complete period is 2 pi. So this is a standard period. It means that b equals 1. b equals 1. It is just cosine x. Minus 6 plus 2 cosine x. Now let us graph cosecant x. Cosecant is a reciprocal function, and we graph such a function in 2 steps. First, we graph its reciprocal, let us call it y prime. We keep all the coefficients, so the amplitude -4, b is 1. What is the reciprocal of cosecant? So we have c here, so in the reciprocal function we'll have s sine x. We will graph -4 sine x. Sine is limited between 2 lines, y equals -4 and y equals 4. The period is a standard sine period, 2 pi, since b is 1, 2 pi. So, and sine is negative, it means it starts downward, start decreasing. So to make a graph, we need to show middle point and quarters. So to make it better, so at the quarters it will have first minimum, then at the third quarter maximum, and 0 in the middle. Now we draw this negative sine graph with the dotted line. Now the cosecant. Cosecant is 1 over the point on this line. So it means that when the sine has 0, the cosecant will have vertical asymptote. It will increase without bound. And when the sine function has minimum or maximum, cosecant function will have the same value. It will touch this point. Now we can draw this cosecant. You can always check your graph by substituting some of the values. For example, pi, if you take pi over 2 and substitute in the equation cosecant of pi over 2, cosecant is 1 over sine. Sine of pi over 2 is 1. So 1 over 1 is also 1 times -4. The value is -4. So we are at this point. So, and the second branch of the same graph goes upwards. So this is the graph of -4 cosecant x. The second part of the exam from chapter 5, using the trigonometric identities. So let us simplify or transform this expression, tangent x over cosecant x minus secant x. And when you see this function tangent, secant, cosecant, the best way is to switch to sine and cosine, to rewrite this expression in terms of sine and cosine. So tangent is sine x over cosine x. It is divided by cosecant. Cosecant is 1 over sine x minus secant 1 over cosine x. Wait a minute, here was secant x, so which is 1 over cosine x. So now we can work with this identity, with this expression. In the first fraction we have denominators cosine and cosine. Above and below we can rid of these denominators by multiplying by cosine x, numerator and denominator. Cosine and cosine will be cancelled. We get sine x over 1 minus, yes, and here was cosecant, so 1 over sine. Sorry about that. So minus 1 over sine x. We want to add or subtract these two fractions. We need the same denominator. So the common denominator will be sine x. So we must multiply by sine, numerator and denominator in this fraction. So it will be, we multiply by sine, and here we also multiply by sine. In the numerator, the first term will be sine squared x. From the second fraction, we have minus 1 divided by sine x. Sine squared x minus 1, you should be good by recognizing this. This is a part of a Pythagorean identity. The most basic Pythagorean identity is sine squared x plus cosine squared x equals 1. So you can solve it either for sine or for cosine, subtracting one of them. Let us subtract sine squared from the left and from the right. You'll get cosine squared x equals 1 minus sine squared x. You see, it's almost the same expression that you have in this fraction in the numerator, only multiplied by negative 1. So if you multiply by negative 1 this equation, you will get negative 1 plus sine squared. You see, sine squared minus 1 is equal to negative cosine squared. So you have negative cosine squared x divided by sine x. Sorry. You can rewrite it without fractions. You can rewrite 1 over sine as cosecant. So it is equal to negative cosine squared x times cosecant x. Use sum of difference identity to find the exact value of cosine 165 degrees. Sum of difference, it means that we must represent 165 as sum of difference. For example, 120 plus 45 degrees. So it could be something else, but 120 minus 45. We usually take this pair of angles from the angles from the unit circle, like 30, 60, 45, 120, 150, the angles like this. And you can take different angles. If this sum is correct, then you will get the same correct answer. And then you use the cosine of sum identity. Cosine of a sum equals cosine of the first 120 times cosine of the second 45 minus sine of the first of 120 times sine of the second of 45. Now we substitute the values from the unit circle of cosine of 120 and 45. Let's remind where on the unit circle this angle are situated. 45 degrees is in the middle of the first quadrant and has both sine and cosine equals square root of 2 over 2. And 120 is here. It is 2 pi over 3. It has negative cosine, so x coordinate is negative. And you know, all these angles that are connected to 30 or 60 degrees, one of them always has square root of 3 over 2 and another 1/2 one of the values, sine or cosine. So here the shortest leg is negative 1/2 of this triangle and the longest square root of 3 over 2. Sine is positive square root of 3 over 2. And let us substitute the values. Cosine of 120 negative 1/2 multiplied by the cosine of 45 square root of 2 over 2 minus sine of 120 square root of 3 over 2 times sine of 45 square root of 2 over 2. So both fractions have the same denominator, 4. And in the numerator we have negative square root of 2. And here we have a product of 2 square roots. We can write this product as 1 square root, square root of 3 times 2, or square root of 6 minus square root of 6. You know that actually you can find this cosine using a different formula. The formula for half angle. So 165 will be half of 330 degrees. It's also an angle on the unit circle. And if you use the half angle identity, you'll get the different formula. So it's possible to show that the two expressions are equal. So you will get something like square root, negative square root of, here will be this 1 plus cosine of 330 degrees. Yes, plus cosine of 330 degrees. It's possible to show that it is the same, but if you are asked to use the sum or difference identity, then I am waiting for you such an expression. The next one, the sine of 165 degrees. This is almost the same, but we use the formula for sine for sum of 120 plus 45. In the sine formula we have sum, and in the sine formula we have a product sine times cosine. Sine 120 times cosine of 45 plus cosine of 120 sine of 45. So now substitute. Sine of 120 is square root of 3 over 2. Cosine of 45 is square root of 2 over 2 plus cosine of 120 negative 1/2 times sine of 45 square root of 2 over 2. Again, we have two fractions with denominator 4. In the first fraction, square root of 2 times square root of 3 will be square root of 6 minus square root of 2. Let us write the expression as a single function of theta. Again, we have cosine of a sum, but here one of the angles is a quadrantal angle and another angle is just angle theta. And we can use the formula for cosine sum formula for theta plus 3 pi over 2. The first term is the product of cosines, cosine theta times cosine 3 pi over 2. In cosine sum formula, we have minus the product of sines, sine theta times sine 3 pi over 2. We can find 3 pi over sine and cosine of 3 pi over 2 on the unit circle. Let us locate this angle. 1 pi over 2, 2 pi over 2, 3 pi over 2. 3 pi over 2 is here. It is also 270 degrees. On the unit circle, this point has coordinates 0 and -1. 0 is the x-coordinate and -1 is the y-coordinate. It means that cosine of 3 pi over 2 is 0 and sine is -1. This is 0, this is -1. So the first term disappears and the second term will be negative sine theta multiplied by -1 or positive sine theta. I use a double angle identity to find the exact value of expression 2 sine 3 pi over 8 times cosine 3 pi over 8. This looks like a part of double angle sine identity. Let us look at this identity. 2 sine x cosine x equals sine of 2x. So we have this part here. It means that x is 2 pi over 8. And according to the identity, this expression must be equal to sine of 2 times 3 pi over 8. Let us simplify this expression of cosine. Again, 2 in the numerator, 8 in the denominator. We can divide by 2 numerator and denominator. And it is equal to sine 3 pi over 4. And this is one of the angles from the unit circle. Let us find it on the unit circle. So pi over 4 is the half of the first quadrant. Then 2 pi over 4, 3 pi over 4. 3 pi over 4 is in the middle of the second quadrant. So its sign will be positive, and the value of this sign is square root of 2 over 2, same as with pi over 4. Another example of applying sine sum identity. Here also one angle is unknown, another angle is one special angle. Let us find sine of x plus 135. It will be equal to sine of the first, sine of x times cosine of the second of 135 Let us find it with minus this time. So in the sine identity, we have minus, then minus is in the formula minus cosine this time. In the second term, we have cosine of the first, cosine of x, times sine of the second, times sine of 135. So now we can substitute the sine and cosine values of the angle 135 degrees. It's actually the same angle that we had in the previous problem in the middle of the second quadrant. Both sine and cosine have value square root of 2/2, but cosine is negative. So here we substitute negative square root of 2/2, negative square root of 2/2 times sine x minus, and sine of 135 is positive. We substitute positive square root of 2/2 cosine x. We have one long problem, relatively long problem here. Given the cosine of 2 theta, which is 2/5, find sine theta and cosine theta. This is a problem for half angle identity. So since we are given double angle and we want to find angle, so actually you can use double angle identity. Only that it will be longer and more tricky. It's much more easier. Just take the half angle identity first for sine. Sine theta equals positive or negative square root 1 minus cosine theta over 2. In the half angle identity for sine, we have minus. In the half angle identity for cosine, we have plus. So, and we have plus minus in the beginning in front of the square root. We determine which one we take, plus or minus, from the information about the quadrant. The quadrant 4 here. In this quadrant, cosine is positive, but sine is negative. Sine is the y value. Y value is negative below the x-axis. Cosine is x coordinate, so to the right from y-axis it is positive. So we choose negative sign for sine of theta. And then we just substitute the given value of cosine of 2, sorry, here must be 2, cosine of 2 theta. So we have negative square root of 1 minus 2/5 over 2. Now we have to simplify this complicated expression. So we have 1 minus 2/5 in the numerator. Let us represent 1 as 5/5. Then we have the same denominator, 5 minus 2/5 will be 5/2 minus 2/5 divided by 2 minus square root of 3/5 divided by 2. So when you divide the fraction by a number, you write this number in denominator form. So you can think about it that you divide by 2 is the same as you multiply by the reciprocal. Yes, square root of 3/5. You divide this fraction by 2, or you multiply by 1/2. 2 is in the denominator. So we have 3/10, square root of 3/10. And maybe we want to rationalize this denominator. Negative square root of 3 over 10. Negative square root of 30 over 10. Let us also find the cosine of theta. Cosine of theta, the similar formula, plus minus square root of 1 plus cosine 2 theta over 2. So in the formula for cosine, we have plus here. And we can choose the sign, look at the quadrant. In the quadrant for cosine, the x-coordinate is positive. So we choose plus. Now let us substitute cosine of 2 theta. Will be 1 plus 2 fifths, and it must be divided by 2. The same procedure, we represent 1 as 5 over 5. Now we have both fractions have the same denominator. We have 5 plus 2 over 5 divided by 2. 5 plus 2 is 7 divided by 5, and divided by 2 or multiplied by 1/2. So 2 is also in the denominator. Square root of 7 over 10. Multiply numerator and denominator by square root of 10, and we get 7 square root of 70 over 10. This is the cosine of theta. There will be 15 problems on the exam. I have combined some of the problems here on the review into one problem. So for the first part, there's not much work to show, but for the second part, it will be very helpful if you make the photo of your work and upload it by the 16 problems for possible partial credit if needed. If not, usually the exam is not difficult. You will get small formula sheet, but on the formula sheet there are no graphs for sine or cosine or secant, so you should remember how some basic graphs look like. I wish you good luck on the exam.